So just like we have Amazon AWS, Google GCP, and so on, so it's a cloud platform that contains lots of services. And you can choose to use as many of those services as you see fit to meet your business requirements. So here our goal will be to utilize it specifically to deploy our applications, especially by using AKS, Azure Kubernetes Service. But overall, it's capable of building our applications, managing them, and deploying the applications. So it contains the entire DevOps uh, collection of tools like CI/CD sort of process can be implemented and so on. And obviously, there are lots of benefits. That's why we usually use some cloud platform. Like in case of Microsoft Azure, it's a highly available, scalable, elastic solution that can be scaled out, and you can handle as much load as you can throw at it. So it all depends on your business requirements and your SLAs and so on, like how many users you want to support. So as long as you keep paying Microsoft, yes, you'll keep on getting more resources and you'll be able to support pretty much unlimited load. So basically, there are lots of factors of why we prefer using some cloud platform. So keeping this in mind, that it's a cloud platform that allows us to implement the entire DevOps CI/CD sort of pipelines, plus you can deploy your application, manage the applications, and so on. Let's talk about some cloud models or the deployment models. So Azure allows us to use infrastructure as a service, container as a service, platform as a service, and software as a service sort of models when it comes to deploying our applications. Now, what exactly are these? So in case if you're already familiar with it, well and good. If not, let me discuss these here by showing you this particular diagram. So typically, when it comes to deploying our applications, if you're using your on-premises environment that we can call a private cloud, typically you're responsible for the whole thing. Like you need to make sure you have storage like RAID, NAS, SAN. You need to have network in place. You need to have compute resources like CPUs and so on. And then typically we try to install some virtual machine, then some operating system, and then we install various dependencies or packages or SDKs or JDKs like Java Development Kit, .NET Framework, .NET Core, PHP, Python sort of dependencies will be installed, and then you get to deploy your actual application and your actual data. So typically you're responsible for managing the whole thing. And if you plan to use any cloud platform as, or even your on-premises sort of environment where you have some cloud setup, or actually let's not talk about on-premises, let's talk about cloud-based setup. So in case of any cloud-based setup, if you want to use it as infrastructure as a service, you will only be responsible for what we have in green. What we have in blue will be the cloud vendor's responsibility. Like the physical storage, you never get to see that. Networking, you never get to see any network equipment. You do not get to see any physical compute resources. So you are typically only responsible for a virtual machine. Some OS of your choice needs to be installed, and then you install your JDKs, SDKs, and other dependencies like, let's say, application servers such as JBoss, WebLogic, WebSphere, and then you get to deploy your applications and your actual data. Now, in this case, we have some drawbacks that I'll talk about in detail in just a bit. But before I talk about the drawbacks, we have the main focus of this session that is known as container as a service, CaaS. So in case of container as a service, notice that you're responsible for fewer things, less things. So the major benefit here you can see is that you're not responsible for any hypervisor. Like you do not need to have any virtual machine created. You do not need to allocate resources. Like I need to have 4 GB of RAM, 2 CPUs allocated to a virtual machine. You're not even responsible for managing or securing any operating system. So even the OS will no longer be your concern. Your only concern will be these things, like install your dependencies like JBoss if you want to use that, or any other application server of your choice. JDK can be installed and stuff like that. And then you get to focus on your actual application and data. So container as a service basically removes some of these things off your plate. You're not responsible for any OS. And that makes sense. Like at the business level, when you need to deploy your applications, the business doesn't care for whether we plan to use a Linux distribution or a Mac OS or some version of Windows. So no one cares for that. So that is why container as a service says focus on what you really need, like just the dependencies such as JDK, some application server, or if you're using Java with Spring Boot, you already have a built-in application server and your Java Spring Boot applications. And you basically just focus on your applications and maybe JDK and just your data. So basically, this is the main focus of this particular session, and we will see how we can use container as a service option on Azure. Although we do have some more options here, like you can use any cloud platform as a service as well, but this is not the main focus of this session. But still, I'll just quickly summarize it. So in this case, you typically use, let's say, something that is known as an app service, or you can call it a web app on Azure, where you just deploy your actual application. And the runtime, like do you plan to use PHP or JDK, all these runtimes will be provided by the platform as a service component of the cloud platform you plan to use. So think of it as very much similar to what people have been doing since the very beginning of the internet days. Like when people host websites on any uh, cloud platform or on any provider, provider or something like that, uh, we typically just focus on the actual application and the data, and the runtimes, they are pre-installed for us and so on. So you can see that container as a service offers us more flexibility because you get to control exactly what runtimes you want to install. Do you want to use Scala? Do you want to use Golang? Do you want to use some other language that is not very common? Sure, you can do that. You can install a runtime of your choice and just focus on your actual application after that and your data. So keeping this in mind that container as a service is one of the cloud models, let's focus on this in more detail. So what exactly is that cloud as a, or container as a service? So container as a service, in a nutshell, utilizes a couple of very important and very popular technologies, such as Docker and Kubernetes. And Docker is what that allows us to really focus on the containerization concept that we can later on deploy to Kubernetes. So the question is, what is Docker and what is containerization? So before I talk about Docker in detail, let's talk about this containerization concept in a very generic manner. So in general, containerization is about being able to, let me switch over to this particular, sorry, I thought I had it in this one ready. Okay, that's more like it. So basically, if you recall, we discussed that in case of virtual machines, we typically have a virtual machine that we set up on some infrastructure. We have some host operating system, and then we get to install an OS of our choice, and then we get to install our applications and perform the deployment and so on. Whereas in case of containerization, you will notice that you're only responsible for your runtimes and your actual application. And there will be something available to us that is known as a container runtime that will be offered to us mostly by Kubernetes, something we will discuss in detail later on. And the goal is to make or application platform independent and make it more portable, basically. So for example, if you have a containerized application, we will discuss Docker in more detail in just a bit, but in short, when you have a containerized application, it will only contain your dependencies such as JDK/JRE. Your actual application will be there, and that is it. There'll be no OS at all. So what about the OS? So where will those OS level services come from? Who will provide the services to us? And the answer is your actual operating system where you plan to deploy your containerized application. So when you have a Docker slash containerized application, you can deploy it to any Linux distribution. You can deploy it to your Windows OS, to your Mac OS, and also it can be deployed to any cloud platform like Amazon AWS, Microsoft Azure, Google GCP, and so on. So basically, the goal is to be able to make our application portable, package it in such a manner it should work everywhere or anywhere. So it's a way to package our application to make sure it runs anywhere. So keeping this in mind, let's cover Docker in slightly more detail before I show you a demo. So eventually, by the time we are done with this session, you will notice that we will have our regular application, a Java-based application, let's say. We will end up creating a Docker image, and then we will deploy it to AKS or Azure Kubernetes cluster. So Docker, in a nutshell, is one of the technologies. It's a very popular technology that allows us to package our applications. We can create images. Each image is essentially a bunch of files that will contain all our dependencies and our actual application. So basically, it's used to sort of virtualize our application. So rather than virtualizing the entire hardware, we just virtualize our application that contains all the dependencies. So the goal is to containerize our application or isolate it from our host operating system. All the dependencies should be self-contained. The self-containment, that is one of the goals of Docker. So contain all the dependencies and your actual application. So this way we should be able to deploy it wherever we want without focusing on, oh, do we have some dependencies in the program files folder or in some other OS level file system sort of folder. So we shouldn't be worried about that at all. So it allows us to create a self-contained image that contains all the dependencies. And this way we will be able to isolate our application from our host operating system and also from the rest of the applications as well. So, and the benefit is that once you have isolated your application, there will be less chances of having issues like if one application gets corrupted, there's less chance that it will end up corrupting the file system or the application that we have in some other container. So basically, it will be an isolated application, and just because the application will be isolated doesn't mean they cannot talk to each other. They can still communicate by using the REST API sort of concepts. Service endpoints can be used. We can also use something that is known as a shared volume. It's basically an advanced technique we use to share some file system or some folder or files across multiple containers. So we can share content across multiple containerized applications by using a shared volume. Or you can also choose to use environment variables so that you can pass some values to your containerized application. So basically, you get to have a portable, isolated, self-contained application because of Docker. So in a nutshell, it allows us to package our application or create an image that can be later on deployed. In this session, we will mostly focus on how to deploy it to Azure Kubernetes Service, AKS based cluster, but you can choose to deploy it to, let's say, an app service as well on Azure if you want. And Docker runs everywhere. Like it can be used in your on-prem environment, on pretty much any major operating system, or also on any cloud platform as well. And here we'll focus on Azure. And mostly what you have to do is, in order to use Docker, you need to make sure that you install the Docker service. And it's totally open source, free of cost technology. And here I have a Windows-based machine here, and I already have Docker Desktop. It's a totally free of cost, open source technology available for Windows, Linux, Mac OS, and you can choose to install this on any OS, like I mentioned. So here I have it installed on my Windows-based machine. So make sure Docker is installed, and then all you have to do as developers is to create a script called Dockerfile. The Dockerfile is a script that we need to create. So for example, here I have a simple Java Spring Boot application. You can see that I've already compiled my application. It's a simple REST API. If I run this particular application by using Java -jar, it will start up the Spring Boot's built-in application server, and the REST API will be available to us. So it's a very simple REST API, and I want to show you how to containerize it and also how to deploy it to AKS. So here, if I, let's say, first of all, quickly switch to Postman, so I can test the endpoint. So this is the URL I can use to access the REST API. It's a simple JSON sort of output. So regardless of how complex your application is, you can use Docker to package it, and then you can deploy it to Amazon AKS cluster. Now, question is, how do you package it? How do you create this Dockerfile script? So here, we will not get into too much depth of the entire syntax, but here, if I let's say switch to this one. Again, as a reminder, some of these demos are fairly time consuming, so I've pre-recorded some of the demos so that I can speed through some of the steps, and you will be able to watch all this stuff once we're done with the session by going to the portal, and you can download the video recording as well. So basically, you need to make sure your Java, Spring Boot, or whatever application you have, in addition to your source code, it should contain a script called Dockerfile. And the Dockerfile script, typically it looks like this. So I won't go into too much depth of what each line means, but for now, just know that we get to specify some base image that contains all the dependencies that our application will end up using. Like in my case, my Java Spring Boot application needs JDK, and in particular, it needs JDK 8. And I'm also specifying what port number will be used by my Spring Boot application. So it's 9001 in my case. You can choose to use port number 8080 or just 80. It's up to you. For now, I'm using this particular port number. And then we are copying the compiled application that we have on our local machine into a custom image. So we plan to create a custom Docker image. And to do that, we are basically copying it into the custom image at this location. And then very importantly, the last step, entry point, is specifying how to execute the application inside the container. So once the application is containerized, how exactly it's supposed to run the application, we are specifying that as an entry point. So basically, what does this mean? So what it means is that typically when you end up creating your applications, and preferably we try to use the microservices architecture these days, you will end up having at least one project, otherwise multiple small projects. And typically we do try to use Git or some other source control repository like CVS or SVN. So here we are planning to use Git. So if you have your application checked into your Git repository, this particular project, or in short, each project must have its own Dockerfile script. So you will basically end up building your Docker images. You'll build your Docker image that will contain all the dependencies along with your actual application. Initially, it will be there on your local machine. just so you can test things out. And after that, you will end up deploying it to Azure. So Azure wise, let me give you a sort of level of a view of this architecture right away before I show you the demo. So you typically test your Docker images on the local machine first, just to have confidence that things are working. And once you're positive things are working, now you plan to migrate or deploy your applications to Azure. So that's where we usually create something that is known as an Azure Container Registry, ACR. So this container registry will be where our images, build images. Images means all the dependencies and the actual application for each application will be built as an image and will be hosted on Azure as part of this Azure Container Registry. So if you have two applications, you will end up having two images, and you will have to deploy or host them on Azure as part of your Azure Container Registry. And then later on, you get to deploy them, you get to run them, execute them. So these are just images. They are just sitting on some file system. They're not doing anything at all. So you need to run them. You need to execute them so that your services should become available to us. And that's why we typically use AKS, Azure Kubernetes Service. So what exactly Kubernetes Service is, I'll talk about that in detail later on. For now, know that each Docker image will be deployed to your AKS cluster so that it can offer us the Kubernetes specific benefits. And what are those benefits? I'll talk about that in just a bit. So coming back to this point that each application will contain your actual source code. You will be responsible for compiling it, and then you will be responsible for packaging it by creating this Dockerfile script. And typically each Dockerfile script looks something like this. It does vary depending on what base JDK or image you want to use, where you want to copy the files, how you want to start up the application. Like in case of .NET, you will have to use a different command and so on. So basically, once you have this Docker file, you can execute this Dockerfile script by using this docker build command. So this will end up running this particular Dockerfile script, and it will create a custom image named restaurant API in this particular case, and it will be tagged or labeled as latest. So tags or labels, you can use them for versioning and so on, like version 1.0, version 2.0, and so on. So when you execute this command on a machine where you have Docker installed, after that, you can choose to obtain how many images we have on the system. So we will end up seeing this particular image, like we have just one at this point, restaurant API. And notice that the file size is fairly small. Think of it as an alternative to using a full-blown virtual machine. We are virtualizing not the hardware, not the operating system, but just your application. So just your application is now self-contained in this image that is sized 147 megabytes. So it's a self-contained image that contains JDK. So there's no dependency on your JDK that we have at the host machine. You don't need to have JDK on your host machine. Everything is packaged in this small image. So typically each image is just a few hundred megabytes in size. In very rare case, you will have maybe a GB or maybe a couple of GB worth of or sized images, but that's fairly rare. Typically, they are just a few hundred megabytes in size. And that's where we use the microservices architecture term as well, because we usually end up having multiple small deployable images, and you can deploy them to Kubernetes on your local machine or on cloud and so on. So basically, so far we have seen that in addition to having your regular Java-based application source code, like here I've the source folder with the .java files and so on, and I'm using Gradle as the build engine here, but that's not the main thing. You can choose to use Maven if you want. The only thing that's specific to Docker is this particular file, Dockerfile. That is it. So we have this Docker file, and you run the Docker file by using Docker build. And after that, what should be the next step? So the next step should typically be to test it out on your local machine, just to have confidence that this self-contained image works. So for that, you can use this command, docker container run. -d means run it in the background as a daemon. This is the name we want to assign to our custom container. So we want to basically run this image. So this image is currently sitting on the hard drive. That's the size of the image, but we need to run it. We need to load it into our system's memory and execute whatever we have in that Docker container, or the Docker image. So that will be the name of the running instance of the Docker image. And here you can choose to specify the port mapping. Like as a developer, you need to know what port number your REST API will end up using. So that will be the internal port number. And externally, from your local machine or from a remote machine, what port number you want to be able to use to connect to that application running inside your container. So you can choose to perform port mapping. Like you could say internally it should be 9001, but externally it should be port number 8080. So this way you'll be able to use whatever the IP address is of your running container, and then specify this external port number or the mapped port number. And this is the image we want to use to create a running instance. So basically, once you run this command, it will barely take just a couple of seconds or 2 to 3 seconds or so, and you will have your containerized application up and running. Unlike VMs that take several minutes to start up the OS, and then you have to wait until all the services have loaded. Then you interact with the user interface and you go to some folder, you run the application. In case of containerized applications, it's very fast to start up our application because there's very little overhead here of the operating system and so on. And next, you can test it out by, let's say, using Postman or any other application, or REST client testing tool can be used. Enter the URL. So here you'll be able to see the output. So in this case, we have a REST API sort of application. But typically, when you have a microservices architecture, you will end up having REST APIs, and you will also end up having the web front end that could be React, Angular, jQuery sort of application, and so on. So for now, we just have a single REST API here. We don't have any web front end. Okay, so we have tested out the containerized application. It's running. And you don't need to have JDK installed on the local machine to run this container or run the image as a container instance and test it out. So basically, we have created a Docker image and we have tested it. It's running, it's working properly. So now you can choose to, let's say, stop your container. We don't need it anymore. We can use Docker stop to stop it. We can use Docker rm to delete the container just from the local machine. The image will be kept intact. Just the running instance or the process will go away. So we are sort of killing the process. We are terminating the process because we have tested out the application. So we are done with the building of our Docker image. It contains our Java Spring Boot application. Now, what should be the next step? So next, we need to publish it. We need to push it to Azure, because on Azure, we plan to use Kubernetes Service. So we'll talk about Kubernetes Service in more detail in just a bit. But before that, you need to make sure that you push your image to Azure. It's hosted on Azure as part of something that is known as Azure Container Registry. So this is your private registry that you own as an organization. So no outsider will ever get to see what images you have. So you need to push them to this Azure Container Registry. Now, how do we do that? So for that, we need to install Azure CLI, AZ command line tools. and then you need to log in into your Azure environment by using AZ login. And once you have logged in fact, it will show you a URL. You need to enter this URL into any browser. It will ask you to log in with your valid Azure credentials. And this is another reason why I've pre-recorded the video so I could mask some of the content. Like later on, you'll see some IDs, like subscription IDs and so on. And I wanted to keep some of the stuff private. So that's why I've pre-recorded the video to save time and to hide some of the important information. Okay, so once you have logged in, your command line instance will be authenticated, and now you'll be able to perform operations on Azure by using your AZ command. So here I'm going to specify my subscription ID. Again, I've masked it. So you need to specify exactly where on Azure, what subscription that gets billed, you want to use that to deploy your applications. And then I'm going to do a bit of homework here. Like I'm going to create something that is known as a resource group in the East US location. And more importantly, I'm going to create this ACR. And actually, this is not critical, so it's okay if you guys see it. So basically, once you have created a resource group, next we need to create that Azure Container Registry by using AZ ACR command. So this AZ ACR command will basically end up creating this container registry on Azure, where you'll be able to push your local Docker images to Azure. So we are doing a bit of homework by creating this Azure Container Registry on Azure. So this AZSCR command will end up creating the registry for us. You can verify that graphically as well by opening up your Azure portal. You can go to your resource group of your, the one that you created previously, and there you'll be able to see your AZSCR instance as well. And when you switch to that instance, you'll be able to see something called login server that is required so that later on you can push your images, Docker images, from your local machine to Azure by using this login server name. So make a note of this login server name. I'm storing it in a variable. And a very, very important step. In order to push your local Docker images, Docker images that are available on your local machine in your local Docker server, you need to push them, you need to upload them, deploy them to Azure. So for that, we need to make sure we tag the local Docker image. It must have the login server as the prefix. So whatever this login server is, we obtained from Azure. We need to make sure that the local Docker image is prefixed with that. So this $login server is a variable name. It will obtain the value and it will act as a prefix. This is the most important step here. Without this step, you will never be able to push your images to Azure. So now if you get the Docker images list, you'll notice that we have the previously built Docker image, and we also have the same Docker image. Its name is this one. So we have sort of renamed it. We have tagged it. So we have this particular tag assigned to this particular Docker image. So this is how we'll be able to push your the images to Docker, or sorry, to Azure. So now if you use Docker push, it knows that it needs to use this login server. You can see the actual name here. And since we have already used the AZ login command, so the command line instance is already authenticated, so it will be able to push the images to Azure. So now it's basically preparing the images, and it will push the images to Azure. And to verify that you have the images pushed to Azure, you need to first of all log in into ACR by using AZACR command. This will basically log in this particular command line session. And actually, we are done with push. I ended up reversing it a little bit. And if you want to view the images that you have pushed, currently we have just one. You can use this particular command, AZACR repository list. it will show you what images we have pushed from the local machine into Azure. And in fact, you can choose to do most of these things graphically as well. Like if you go to the portal, if you, let's say, go to your container registry here, you'll be able to see what images we have available here that we have pushed from the local machine to Azure. So if I switch to repositories, you'll be able to see the repository or the image here. So we have restaurant API as the image, and you can even see how many versions we have. We have just one version. We have tagged it as latest. Otherwise, you can tag it as version 1.0, v 2.0, and so on and so forth. So basically, what we have accomplished so far is we have our Docker image on the local machine, and that is now also available on Azure. Overall, architecture-wise, we have this particular project. We ended up building the Docker image on the local machine by using the Dockerfile script. We ended up creating this Azure container registry, and we have pushed the image to Azure container registry. So it's available on cloud now. Ignore the second project, but if you have a microservices application, you'll end up doing the same thing with each and every application. So build the images, test them out on the local machine, push them to Azure, and so on. So we are done with up to this part. Now, the images are available on Azure, but they are just sitting dumb on the hard drive on Microsoft servers. They're not running. You cannot access them. There's no REST API service available to us because it's just running on the hard or sitting on the hard drive. So next, we need to make sure we deploy it. And before deployment, notice that even in the video recording, I ended up showing this repositories that is a part of the ACR. And before you deploy to AKS service, Azure Kubernetes service, typically we test it out on Azure as well. So just like we previously built the image on the local machine, and then we tested it on the local machine. Likewise, after pushing the image to Azure Container Registry, ideally we should test it out on Azure in a standalone manner before you deploy to a full-blown Kubernetes service. So to test it out in a standalone manner, even if you do not have the AKS Azure Kubernetes service, we can choose to create a standalone instance of this particular registry, or sorry, the image. So graphically, you can just click on the image and then click on the version or the tag, and then click on the three dots or the ellipses here. It will let you create a standalone instance. So you can run an instance of this particular container or image. So you can name your container whatever you want, just for testing purpose. We are doing it like this right now. And next, also make sure you specify the port number that you want to expose so that you can access your application. And once your container has been deployed or it's up and running based on the Docker image, you can choose to go to container instances. And in container instances, you'll be able to see the up and running instance, like restaurant API is container instance is available. It will show you the IP address assigned to this running instance. So make a note of this particular IP address and either use any browser, or you can go to Postman, enter the IP address, colon, port number, and whatever your endpoint is, you'll be able to see the result here. So in short, we our deployed image or pushed image is properly pushed to Azure. It's functional, and now we should be able to use the full-blown AKS Azure Kubernetes service cluster. Now, talking about Kubernetes, before I explain this command, so what exactly is Kubernetes? So Kubernetes is basically a deployment platform. So Docker is used to build images. Kubernetes is used to deploy images, run them, manage them. So it's a container deployment platform. And it allows us to expose services so that other microservices can talk to that exposed service. So there should be inter microservice communication in place. And the most important benefits, we can implement scalability that I'll talk about practically as well in just a bit. So you can say that we have too much load on the system. We need to scale out our application. We need to have 5 replicas, 10 replicas, 15 replicas, because we want to handle load. And it's very fast to scale out our application when you have it deployed to Kubernetes. So it's a scaling system that also offers us with load balancing and also with auto failover. So if an instance has crashed, it will automatically fail over the traffic to some other instance without causing any downtime. So there will be no downtime, and your applications will continue to run. So scalability, auto failover, load balancing, these are the most important benefits. So Kubernetes is a deployment platform where you deploy Docker images, and then they will be started up as container instances by Kubernetes, and it will offer us with these benefits. And you can use Kubernetes wherever you want, like in your on-prem environment and also on cloud. So here in this session, we just want to focus on Azure Kubernetes Service, how to use it on Azure, but know that it's possible to use Kubernetes on any local infrastructure as well. So keeping this in mind, that Kubernetes offers us with load balancing, auto failover, scalability, and so on. Our goal is to deploy our Docker images. So these are the images available, or at least one image is available on ACR, Azure Container Registry. We need to deploy it to Azure Kubernetes Service. And AKS, or Kubernetes in general, will start up a container instance based on that particular application. And Kubernetes will use something that is known as pod. So each pod is basically a service or a feature of AKS or Kubernetes in general that basically offers lots of benefits, like it monitors this container. Is this container up and running or not? And it basically is responsible for communicating with Kubernetes that something bad happened, and then Kubernetes will basically replace the damaged pod with another healthy pod and so on. So basically, we need to make sure we have the Kubernetes cluster provisioned, and then we deploy the image to AKS as a pod. So first of all, we need to provision the Kubernetes cluster. Say I'm running a command that will set up a Kubernetes cluster for us from scratch. So this takes about 5 to 6 minutes or so. That's why I've pre-recorded this video. I've removed some of the important IDs that I don't want to display here. And once you have your Kubernetes cluster up and running, you can search for Kubernetes service on Azure, and it will show you whatever your cluster is that you have provisioned, and you'll be able to see how many nodes we have. So each Kubernetes cluster is composed of at least one node. Otherwise, in real world scenario, usually we end up having multiple nodes. This way, you will have better load balancing and auto failover. So this way, you will not have just a single point of failure. So if this entire infrastructure, this server crashes, we don't want to lose everything. So that is why we typically prefer having a multi-node cluster, multi-machines cluster. But here, for now, we are using just 3 nodes out of the box. Kubernetes uses 3 nodes, but you can choose to have more than 3 nodes if you want. Like you can have 10, 15, or even more than that, but you do have to pay accordingly. So we have our default node pool that's composed of 3 nodes by default. And next, more importantly, I'm going to show you how to deploy our application to AKS. So our Docker image, we need to deploy it to AKS. And we want to do it from our local machine. So we have our local Windows-based machine, and we need to connect to the remote Azure Kubernetes service, and we need to perform deployments. And although you can choose to use a command line tool called kube control, Kubernetes control, but that will be a bit plain and boring way of doing things. So I want to combine it with another tool called Kubernetes Lens. So Kubernetes Lens, it's a totally free of cost open source IDE for Kubernetes. So this particular tool is totally free of cost. So when you launch Lens, it will ask you to specify what cluster you want to connect to. So what Azure Kubernetes cluster or any other Kubernetes cluster you want to connect to. So for that, we have to do a bit of homework. We need to obtain the connection details. So for that, typically we go to Azure and we obtain the Kubernetes config file. And typically you can use the kube uh, CTL get config file or a config view. So kubectl config view can show you the configuration, or you can also go to the default folder that's typically .kube in the profile folder, open up the file named config. It will show you the entire configuration that you need to copy and paste into this K8s or Kubernetes Lens tool. So paste the entire details that contain some security tokens that I want to hide. So that's why I'm masking it like this. So basically, this Lens IDE is now connected to your Azure Kubernetes service or the AKS cluster running on Azure. And you'll be able to see quite a few of these things from here, like how many nodes we have, how many deployments you have, how many services you have deployed, and so on. So we have one node pool, and you can also use the command line tools as well. Like I mentioned previously, you can use the kubectl command to view how many nodes we have. You can use it to perform deployments as well. So here I'm going to perform the deployment. Let me switch over to that since we have less time left. Okay, so now we need to deploy the Docker image to our AKS cluster. So kubectl command can be used to create a deployment. So we need to deploy a Docker image hosted on Azure Container Registry, and that's the name of our Docker image. So whatever your ACR name is slash whatever your actual image name is, like restaurant API is the actual image name, but it's hosted on Azure ACR, not on the local machine. So we need to prefix it with the ACR name. So this command will end up creating a deployment, and you'll be able to see the deployment here as well. So we have the deployment, and once you have the deployment, eventually it will show you the status of available as a status that it's now deployed. Now, even though you have deployed your application, it's not accessible. None of the service endpoints or port numbers are currently available to us. And that's a default security feature in Kubernetes, that none of the deployed applications are exposed as services. So you need to expose your deployed application. And for that, we use kubectl expose deployment. And then there are various deployment strategies or networking strategies, like we can use load balancer, node port, clustered IP. For now, I'm using load balancer. And once you expose your service, it will show you the service and this config, or eventually we'll end up switching to network. Let me switch to network here, or apparently we have already done that. or let me do it by running this command for now. So kubectl get services, or you can go to this network tab, expand it, and click on services. So this will basically show you the IP address that is assigned to your deployed image or the container. So obtain the IP address assigned by AKS to your managed container instance. And now if you replace the URL, like you use the IP address that's available on AKS, you'll be able to hit the service and access the same result that we saw previously. So basically our application is now deployed. And you can also choose to scale out your application. So you can say, I want to have multiple replicas for better load balancing and auto failover and so on. So currently we have just one instance of our application. And if you, let's say, run this particular command, kubectl scale, you can specify how many replicas, instances you want to create. So I want to create 3 instances here for better load balancing and auto failover. And it will show you even here as well that this particular deployment has been scaled out. So we have 3 replicas of this particular deployment. You can also switch to this pod section and it will show you how many replicas we have. So when they're all created, they will all show up here. Previously we had 2, now we have 3 showing up, and they're all up and running replicas. So basically for load balancing, you can choose to configure or scale out your application. You can do it graphically as well, specify how many replicas you want to have. So you can choose to max it out if you want, if you expect too much load on the system. So let's scale it in. So I'm going to switch it, or before that, we are scaling it out to 11. We have 11 replicas, and you can verify them in the pods section. We have 11 pods up and running. They're all up and running now. And you can choose to scale it in if you want. Let's say we want to switch it back to 1 replica. So basically, here we have so far done the scaling out process manually, but in the real world scenario, you can also choose to use the auto scale option as well. So you can say you want to use kubectl auto scale. So based on the CPU utilization or the memory consumption, you can scale out automatically. So scale it out when there's load, scale it in when there's less load. So that is basically also possible. So basically here what we have seen is you can use Docker to build your Docker images, and then you can deploy them or push them out to Azure Kubernetes service. But before that, you need to host them on Azure by using Azure Container Registry. And after that, you can deploy your images available on Azure Container Registry to your Azure Kubernetes service for better load balancing and auto failover purpose. So basically, that's the overall concept. Okay, so here we have talked about these concepts. You can go through the slides as well, but I've mostly shown you things practically. I've explained the overall process there and so on. Okay, so any question regarding this particular session? And we do have a full-blown course. In fact, we have several courses, but one of the important courses is this one. So that focuses on how we can build Docker images from scratch, how we can test it out, what are the various techniques we can use to share content across multiple containers by using something that is known as Kubernetes volume, or in short, just volume. So volumes can be used to share content across multiple deployed containerized applications running on Kubernetes. And we have several other concepts covered as well in this particular course. It's a practical course, it's a hands-on course where we cover everything end-to-end in detail. Okay, so any questions regarding this session? Okay, so thank you very much, guys. It was a pleasure to be here with you for this session. And feel free to contact us if you have any questions.